Hello everyone, my name is Oksana Choporova and the title of my work is Using Machine Learning to Predict the Stress-Strain State of a Rectangular Plate with a Circular Cutout. Machine learning, one of the 6 disciplines of artificial intelligence without which the problems of having machines acting humanly could not be accomplished. Machine learning allows us to teach computers how to perform problems, providing examples of how they should be done. Machine learning is a useful tool for abundant data explaining a certain phenomenon. The world is quietly being reshaped by machine learning. The artificial neural network being its oldest and most powerful technique. ANNs also lead the number of practical applications, virtually covering any field of knowledge. Applications of ANNs to engineering structures arises in a variety of industries such as constructions, automotive, space structures, and others. ANNs allow to develop models, for example, for the stress-strain state estimation of some type of solids. Thus, the development of machine learning methods for predicting the behavior of engineering structures is urgent. In aviation engineering and shipbuilding, the use of prismatic solids with a cutout in which one size is much smaller than the other two is widespread. Such solids could be modeled by plates. Models based on artificial neural networks should take into account the geometric and mechanical parameters of the body as well as boundary conditions. The increasing popularity of artificial neural networks leads to an increasing amount of research devoted to the development of ANN models for modeling various fields. Modeling of solids, the stress-strain state is also possible domain of ANN's application. For example, different authors explore the possibilities of machine learning to solve the problems of fracture mechanics. Particularly in one article, the data of 64 computational experiments and 3 full-scale experiments are used for the training of the neural network to predict possible zones of beam destruction. In another article, a neural network based on the Kalman filter is employed to predict the collapse of a highway on a bridge processing temperature and oscillation data. Another research work shows a combination of principal-component analysis and convolutional neural networks are used to predict the entire stress-strain behavior of binary composites evaluated over the entire failure path, motivated by the significantly faster inference speed of empirical models. Computer-aided design requires the development of methods and software for stress components fast estimation. The classical methods of mathematical modeling, for example, the finite element method, allow to evaluate the stress-strain state with a good accuracy. Moreover, The preparation of adequate mathematical models and the corresponding computational experiments could be time-consuming. A possible alternative is machine learning methods. Artificial neural networks are frequently used in machine learning. ANN could be trained over a data set of an object state and then employed as interactive assistants in the design process. The problem of predicting the parameters of the state of an object by its geometric and mechanical parameters could be classified as a regression problem. The purpose of this analysis is to make a prediction model which be able to predict the stress-strain state of a rectangular isotropic plate with a circular cutout. A plate has parameters such as width, height, radius, and uniform thickness, Young's module, a Poisson coefficient, and edges of a plate may be clamped, simply supported, or free. Researchers' objectives such as developed an algorithm for training and testing models, explore the capabilities of ANN for prediction of maximum plate deflection, and develop a neural network to predict the maximum deflection of the plate. The plate might be of arbitrary sizes, and the cutout might be of an arbitrary radius. Each side of the plate is supposed to be free, supported, or fixed. Additional input parameters of the data set are following: size of plate side, thickness of the plate, Young's modulus, Poisson's coefficient, and pressure load. A data set is generated using the find element method, and parameters of the plate are randomly generated. Boundary conditions are also randomly generated. These values are categorical data. Possible boundary conditions are following: a free edge, a supported edge, a clamped or fixed edge. Any combination of boundary conditions is possible, excluding situations with 4 free edges or 1 supported edge and 3 free edges. So, categorical data, one hot encoded by a vector of 76 values. The randomly generated data set includes approximately 11,000 records. Approximately 7,500 records are left after data cleaning because the maximum deflection must be greater than 10 to the 5th power meters and less 0.2 of the plate thickness. In the first picture, you can see the layers of neurons in the model. The model of an artificial neural network is developed. This model includes few dense layers of neurons. Separate input layers are used for numerical and categorical data. Each input layer is connected with hidden dense layers. Then the dense layer merges the output, the hidden layers, for numerical and categorical data processing. The last layer is connected with the additional hidden dense layer. Finally, the output layer is connected with the last hidden layer. For machine learning, the original set of values is divided into two parts: training and test. The training part contains the values of the input parameters of the results, which use an algorithm for constructing trees. The test part is usually less than the trained part. Its values are used to test, in the case of regression analysis, the accuracy of training. The accuracy of the regression analysis is evaluated by calculating the root mean square deviation of the values calculated for the test part as a result of machine learning from the original values. Input and hidden layers use hyperbolic tangent function as activation. The output layer uses the linear activation. Second picture shows loss function for both train and test sets. The mean absolute percentage error of the model is approximately 20%. The number of neurons in the input layers are the same as the number of elements in input areas. For example, 8 neurons are used to process flow data and 76 neurons are used to process categorical data. A number of neurons in hidden layers is variated to get the minimum of the loss function. The mean squared error is employed in a loss function. So, developed NN allows to predict the maximum deflection of a rectangular plate with a circular cutout loaded transversely by a distributed load. Second picture shows that training has a good convergence. The mean error of ANN predictions is approximately 20%. Prospects for further studies are associated with genetic algorithms using in ANN optimization. The key advantage of an artificial neural network is the speed of prediction. The plate deflection is predicted almost instantaneously, comparing the finite element method. So, a pre-trained artificial neural network could be employed as interactive assistances in computer-aided design. Thank you for your attention.